Derivation of equations of motion by graphical method. Let us derive an equation v is equal to u plus at. Let us consider an object which is traveling under uniform acceleration, has an initial velocity u and it acquires a final velocity v in the time interval t. Let us have some construction part here. Now OA represents u and OA is equal to DC. OE represents V and OE is equal to BC. OC represents T and OC is equal to AD. Now BD is equal to BC minus DC, which represents a change in velocity in the time interval T. Substituting for BC and DC, we have got. By definition of acceleration, we know that rate of change of velocity is nothing but acceleration. So, A is equal to change in velocity by time taken. Now, substituting for A and further substitution, we have got A is equal to V minus U by T. Now, here, transposing T to the left side, we have got, and further transposing U to the left side, we have got AT plus U is equal to V. Hence, we have derived an equation V is equal to U plus AT. Let us derive an equation S is equal to ut plus half at square. Here we are going to consider the same situation which we have considered in the first equation of motion. Here area under the curve is represented by the distance traveled by an object. So here area under the curve is nothing but a trapezium. Let's have some construction part here. The line AD divides the trapezium into a rectangle and a triangle. So, area of the rectangle plus the area of the triangle. Here, OA is equal to U, OC is equal to AD, which is equal to T, and we know that from the first equation of motion we have used A is equal to BD by AD, and now transposing T to the left side where we have got BD is equal to AT. Hence, substituting and further simplification, we have got S is equal to ut plus half at square. Hence, derived the formula. Let us derive an equation 2as equal to v square minus u square. Here also we are going to consider the same situation of an object which is traveling under uniform acceleration. Here, an area under the curve represents the distance traveled by an object. Here, the area which we have considered is an area of a trapezium. And here we have got an area of a trapezium. Here OA is equal to U, OC is equal to T and BC is equal to V. Further substituting, we have got S is equal to U plus V into T by 2. From the first equation of motion, we know that V is equal to U plus AT. Transposing U to the left side, we have got V minus U is equal to AT. Further transposing A to the left side, we have got V minus U by A is equal to T. So, T is equal to V minus U by A. Substituting this value of T into the previous equation, we have got S is equal to V plus U into V minus U by 2A. And now, this represents an identity x plus y into x minus y, which is equal to x square minus y square. Hence, S equal to V square minus U square by 2A. And transposing 2A to the left side, we have got 2AS is equal to V square minus U square. Let us summarize the things which we have learned. First equation of motion is called equation for velocity-time relation. Second equation of motion is called equation for position-time relation. And third equation is called equation for position-velocity relation. Together, they are known as three equations of motion.